So now let's do the next part of organic chemistry, which is the third chemical property. So now for the third chemical property, which says oxidation of alcohol, you need to revise the property that I explained before in the alkanes part. So in the alkanes part, I would have explained about the various oxidation processes and the oxidizing agents that you make use of. So let me just give a small recap about that, so this will be easier for you. So as I've already told you before, first when you have an alkane, and then when you make use of an oxidizing agent, so now will be KMnO4 or K2Cr2O7. So K2Cr2O7 or KMnO4 are the two most widely used oxidizing agents. So and then this oxidizing agent, which is KMnO4 or K2Cr2O7, gives nascent oxygen. So now this nascent oxygen is the reason why this alkane gets oxidized to an alcohol. So this alkane gets oxidized to an alcohol, and then this alcohol will get oxidized to RCHO. So RCHO is an aldehyde. So again you make use of the same KMnO4 or K2Cr2O7, and then after RCHO next will be RCOOH. That means it is a carboxylic acid, and further oxidizing the carboxylic acid will give you carbon dioxide and then water. So and then you'll be having carbon dioxide and water. So first is supposed to be alkane, and then you'll be getting alcohol, and then next will be your RCHO, and then RCOOH, and then finally you'll be getting carbon dioxide and water. And as I've already told you before, every step will, like for example conversion of an alkane to alcohol and conversion of an alkane to RCHO, every step will have a very specific oxidizing agent. But then it is very difficult for you to remember what the oxidizing agents are and what the temperature is. It's good to know, in case if you get confused with the temperatures as well as the specific oxidizing agents. The most widely used oxidizing agent is KMnO4 and K2Cr2O7. This will be accepted because it is a very strong oxidizing agent and is most widely known. So now this is just a small recap, and now since I've explained all this, it is almost self-explanatory under the topic, which is oxidation of alcohol. So since it is a property of alcohol, we will start with the second step, which is nothing but from alcohol. So from alcohol, you will be getting an aldehyde, and then from an aldehyde you will be getting carboxylic acids. You will be getting carboxylic acids, and then from carboxylic acid, as I have told you, you will be getting CO2 plus H2O. This is supposed to be a very good part in which they can ask conversions, or in case if they ask convert an alcohol to an aldehyde, you have to just make use of KMnO4. Or in case if they ask convert an alcohol to carboxylic acid, there is a specific reagent which is platinum at 300 degrees Celsius. You can actually go through that in the alkanes part. So platinum at 300 degrees Celsius is a very good reagent to convert an alcohol to carboxylic acids. So now this is supposed to be the explanation which we have already done before. So let's just take one example for this. So now in case we take the alcohol CH3OH, which is methanol, and then your respective aldehyde will be HCHO. The respective aldehyde is HCHO. So your respective carboxylic acid will be HCOOH, and then finally will be your carbon dioxide and water in case when you oxidize it till the last step. Yeah. So now let's do the next chemical property, which is reaction with carboxylic acid, and this chemical property is known as esterification. So esterification is supposed to be the most important chemical property. So because it is a very good test to find that the alcoholic group is there in the respective compound, because the end product which you get is supposed to be an ester. That's why the process is known as esterification. So when you have an alcohol and then when you add a carboxylic acid to it, you will be getting a product which is known as an ester. And this ester is supposed to be has a very unique smell. It has a fruity smell, and because of which you can easily identify that, and it is a very good test to determine that the compound that we are testing for as an hydroxyl group or the alcoholic group. So that is why it is very important. Like how previously we discussed about addition of sodium, because the brisk effervescence of hydrogen will tell you that the compound has an hydroxyl group. So which is a very good test for the compound to identify that the hydroxyl group is present. Likewise, esterification is also a very good test, because when you add an carboxylic acid to it, then what happens is that a product is formed, and this product is known as an ester, and this ester has a fruity smell. So because of this fruity smell, what happens is that you can easily identify the group in the respective compound. So let's just write the reaction, and then the way to name the ester also will be discussed here, though it is not much important. So first let's just take CH3OH as the initial alcohol, and then next one is supposed to be CH3COOH, which is your your acid which has a methyl group in it. So and then you need a very important reagent, and this reagent is concentrated sulfuric acid. This concentrated sulfuric acid is very important for esterification. So when you add concentrated sulfuric acid, so you will have CH3COO will come here as such. So CH3COO will come here as such, and then you will be having CH3 here. So again it will reach. So it will be CH3COO CH3, and this is known as an ester. So now the way in which you name this will be methyl acetate, because this is a methyl group and you will write the name as methyl, and then you have this CH3 here which has one carbon atom, and then the COO here which has one carbon atom. So since it's two carbon atoms, you will use the root word acetate, because acetate is nothing but a similar to your eth. So ACE is supposed to be it determines two carbon atoms in your common nomenclature or general nomenclature. In IUPAC nomenclature you will make use of the word eth. But then while you name esters like this, you will first introduce the name of your alkyl group, and then next you will consider number of carbon atoms, which includes the carbon atom which is there in the functional group. So in the functional group there is one carbon atom, and in the second R group there is one carbon atom. So two carbon atoms, you can write it as methyl acetate, or you can also write it as methyl ethanoate. You can write it as methyl ethanoate. So now here again it will be very clear for you, because the number of carbon atoms is 2, and apart from the next product will be H2O. This is the next product, which is a byproduct here. So this CH3COO CH3 which is obtained is has a very unique smell, which is a fruity smell. So because of which we can easily identify what the compound, what functional group the compound has. Now let's write one more reaction. So now we'll take C2H5OH, and then we'll take CH3COOH. Okay, CH3COOH is fine, and then next one again you should have con H2SO4. So again you will be getting CH3COO, and then you will be having C2H5. So you will get ethyl ethanoate or ethyl acetate. Ethyl acetate will not be the IUPAC, will not have the IUPAC rules, because acetate, the word acetate cannot be used under IUPAC nomenclature rules. So according to IUPAC nomenclature rules, you should have a clear root word and then a prefix and then a suffix. So because of that, we generally don't use methyl acetate as a common IUPAC name. So we make use of methyl ethanoate here, because eth, which indicates the root indicates the root word, where the root word says the number of carbon atoms. Here the number of carbon atoms are 2, so you make use of ethanoate, and then the methyl will indicate the R group which is present. So this is how you basically name esters.